Hey guys, welcome to another episode of Developer DAO Workshops. Sorry for the delay. We had some troubles on the back end. But today we have Manny with us. I'm sure most of you all know him. He's one of the OGs of the ecosystem and Developer DAO. Manny, why don't you give us a little introduction about yourself?
Hi. Hey guys. So if hopefully you can hear me all right. All good, right? I'm guessing. Thanks, Rafat. I'm Manny, or Coding with Manny. You might have seen me in Developer Down. We're VC5. I'm also, yes, an OG member. I've been around since almost the beginning in terms of Developer DAO. I've also helped out a lot of devs in the channel in terms of Developer DAO. Yes, you can follow me on Twitter. I've also been in tech for probably about 15 years, but I'll probably get into a little bit further in terms of it. But today we're going to be talking about tRPC and signing with Ethereum in terms of a full hands-on workshop, basically. So that's a little bit about myself, but I can get into more details in a little bit.
All right, that sounds amazing. So let's head right into it.
Awesome. Let me just double check because I didn't see if I could actually share my whole screen here. So hold up. Hopefully, no issues. Let's just double check. I also noticed I have 100 bajillion tabs open still.
Do it, all of us.
All right, screen 2. Okay, let me know if you guys can see this.
Yep.
Nice.
They should be able to see.
Yeah. Nice. Okay, awesome. So I am also in the other YouTube chats, but I'm assuming that there probably will be questions that come in. So today we're going to be talking about tRPC and signing with Ethereum as an implementation. So this is a hands-on workshop. It's not like, hey, I'm going to give you some high-level overview and then let you go off with some theory. I'm going to give you some actual coding and practicality. So you'll see a lot of mistakes today. I have rewritten this code multiple times to make sure that it works correctly with the appropriate latest versions. But before we get into it, just like Ropat said, a little bit about myself. You can follow me at Coding with Manny at Twitter. I have been around in the tech scene for probably 15 years. I'm also a developer relations engineer for Polygon, and I dabble in Web 2. I still dabble in a lot of Web 3 in terms of writing Solidity contracts, writing front end work, etc. But definitely follow me in terms of on Twitter. I usually rant a lot about Web3. Small note is that you will be able to see this presentation later and get the link, etc. You will probably just need to refresh it. Yes, you will see the QR code to be able to get this presentation. And I'll update it afterwards as well, because there's a few other gold nuggets that you'll guys get in terms of this presentation too, or workshop, as well as like the code and hopefully a written tutorial that you guys can actually review afterwards as well. So, all right, so back to it. So what are we building today? Today we're building a tRPC React sign with Ethereum Monorepo. Okay, this is the UI that we're building. Essentially, it is a very basic look, but it achieves the functionality that we need in terms of being able to have a front end, use sign with Ethereum, and then be able to connect to essentially a backend to be able to process that and use sessions to be able to authenticate. So using sign with Ethereum to be able, or your wallet, to be able to authenticate yourself with sessions. And this is what it kind of looks like. And we'll get into essentially what that functionality is later on. But first, what is the tech stack that we're using essentially for here? So let's just go over the list of different things that we're going to be using. So our backend, we're going to be using tRPC. Our front end, we're going to be using ViteJS with React and TypeScript. We're going to be setting up the Monorepo with Lerna. We're going to be using PMPM. So a lot of people use NPM or Yarn, etc. I've actually made the switch over to PMPM because it saves you so much time in terms of like not having to re-download all the libraries. It actually saves them locally. So let's say if you're working on a plane or somewhere you don't have internet, it's really great because it actually just downloads all the packages for you or reuses the packages that you already have stored locally. So it's a great way so that you don't always have to build out, like have the same node module folders in multiple projects where it just gets to like 100 gigs on your computer. This is a great way to save space. I definitely recommend switching over to PNPM. And we're going to be using Sign with Ethereum implemented with Wagmi. And if you're familiar with Wagmi, check out wagmi.sh. I've contributed a little bit to their docs. I'm not by any means like the smart people like TMM who are on the actual core contributing team, but I do contribute to the documents every once in a while. I also have other documentation that I'm going to be, or other tutorials in terms of implementing Sign with Ethereum, including a Next.js 13 version with Sign with Ethereum that I just finished as well. So hopefully I'll have that out soon. So that's essentially, you can see amazing explosion sounds, the tech stack, which is amazing. So first off, like, let's talk about Lerna just briefly so that you guys understand what like monorepos are if you're unfamiliar. So monorepos basically is having different, I guess, services all existing in one single repository. And what that looks like is like you have your front end, you might have your back end, you might have, another third-party service, etc. It's basically having as many services as you want, but all within one single repository. Okay, so that's what a monorepo is. It's just like monolithic in the sense that everything is within one repo. Now you can set this up yourself, but one of the issues is, there's a lot to it, and like maybe you still there's some advantages of using Lerna, which is just a way to, and there's other ways actually you can kind of manage monorepos, but it's an easier way for you to kind of set up monorepos, manage them, do parallel installs, parallel running scripts or whatnot, all within the same repo, so that you don't have to go to individual folders and go like yarn dev and yarn dev, right? Or yarn install to all these repos. You can just run one command and it makes it a lot easier. And there's a lot of other things you can do it, but we're going to be using basic functionality with Lerna in that sense. So why not Next.js? Everybody, like, this seems to be like the tutorial default for a lot of tutorials, including, on Wagmi's site, they use Next.js. Why not just use Next.js? One of the reasons, like the main reason, and this is frustrating for me, is because I love Next.js if you're doing SSR or server-side rendered applications. But for most applications, even through being in tech for so long, a lot of applications that are asked by clients are client-side applications or single-page applications. So everything is rendered on the client side. So if you're not familiar with the difference between SSR and client-side or SPAs or single-page applications, is basically everything is rendered basically on the back end for server-side applications. So you need actually some memory, you need CPU processing, whatnot. It actually compiles whatever request that goes into the back end and then presents the final format at the end in terms of the user. So, if you might have a request to a user, you might have some request that goes in, requests the user's information, they're logged in, it'll present it on the front end in that sense. For a single page application, everything's rendered on the client side, so on the browser in this case. And the browser renders it, and then whatever HTTP requests that go through, you can be done on the front end. So there's no extra needed CPU or memory dedicated to this to be able to have these rendered applications going and whatnot. And so to go back, one of the main reasons is that I wanted to take a step away from Next.js in a sense is that there's a lot of single page applications that are built out that are private. So in other words, if you built out an application that, I have a login system and I have personal information, I don't need server-side rendered application for that or whatnot, because, I don't necessarily want that indexed by Google. And that's typically where you see a little bit more lightweight applications that are built within the industry that are just built not using Next.js. Because there's that requirement of server-side render isn't required. And in this case, you're using something like Vite or Create React App, or, for that matter, Svelte or Vite, or Vue for that matter, to be able to build out a front-end application, right? So that's why we're not using Next.js. So tRPC, let's dive into it. Just a basic understanding of tRPC. It is a lightweight version alternative to basically GraphQL. So what that means is, if you're familiar a little bit with GraphQL, it allows you to be able to make multiple requests within a single request, kind of almost like batching requests, right? With the schema that's involved. But here is a tool that allows you, or abstracts the idea of accessing your backend endpoints without actually having to write any schema, or having to write and make it type safe, without having to generate any additional codes or generate any types for your front end as well. Now, one of the drawbacks is that it is actually specific to monorepos, because one of the reasons why you want to have it in monorepo for full stack application is that you'll have access to the types in terms of the backend. So it makes it a lot easier. So tRPC is great in the sense that it just abstracts all that. You don't have to do any additional schemas, etc. And it really is for that full stack developer who wants to build out that front end and back end. So before we go further, let's like talk about like the elephant in the room, like REST versus tRPC versus GraphQL, like what's the base difference, right? And I think you got to think of these as different types of tools, right? They're tools that are needed for specific scenarios, right? So if you think about it, REST is like the traditional, hey, we needed to get away from XML requests or SOAP requests because we needed a better way to be able to handle requests. And that's where REST really came in, is that you have specific routes. That route will follow the convention of get, post, put, delete, or even patch in terms of the types of requests methods that you can perform in those endpoints. And basically that allows you to be able to end up getting JSON, which is consistent all around in terms of the convention of return payload. So REST is really, /user, you get the user information, / post to a user, you might create a new user that way, but the convention's there. Where GraphQL came in is that if you notice a lot of applications, a lot of information was reliant on other information coming through. So I needed to have the user's information to get their user ID, to pass the user ID, to get the to-dos, because I need to pass the to-dos and pass the right user ID to get the user's to-dos in that sense. So you would essentially make two requests in terms of if you made a traditional REST application. You said, hey, I'm going to perform one request, get the user. From a user experience point of view, I'm watching this load, and then I'm watching another loading screen to be able to then pull in the to-dos in terms of a second request that goes through. Now, it's not. Now, that's a very simplistic like example, but there is much more complicated requests that kind of go through with REST with the applications that you're dealing with. In the sense that you might get like 3 or 4 or 5 or 6, 7, 8 different types of information that you need all at once. When GraphQL came in, is that it says, hey, we can perform all these requests in an efficient way within one single HTTP request, pull all the information that you need within that single request, and then you just present it, bam, to the user. So the user experience is dramatically better in that sense, right? But if you think about it, like that was solving a specific use case in terms of being able to follow, hey, I need to follow convention. I need to be able to get all the information from the backend so that I can present it to the user at the end of the day. But one of the drawbacks is, or one of the and also, I guess the advantages is that GraphQL is like you can set it up in a monorepo, but it's typically set up that you'll have it for teams that are, hey, I want to have a front end team that just works on the front end. I just want a back end team that just works on the back end. And basically we establish a schema, or sometimes referred to as like a contract, basically between the two development teams, to say, hey, whatever you build, as long as you follow this schema coming through, then I will consume that on the front end and send it back to the back end in this specific format in terms of the payload. Now, what that does is that you kind of almost need a third team to be able to manage the schema, to be able to understand this agreement between the backend developers and the front end developers, right? And don't get me wrong, there's a lot of like full stack developers who come in and they're like, hey, I'm going to establish my own schema, but I might not necessarily be the most like savvy backend developer to come up with the right schemas in that sense. And it really just becomes cumbersome in terms of being able to manage this. And there are tools to be able to have it type safe as well, where you could generate some code and then it actually generates the types for you on the front end. So it makes it a little bit easier. And you can pull that like almost remotely in some repos that I've seen, where you can just pull in the types and then you can use it on the front end, right? Where tRPC comes in is it kind of takes this a level like simpler, in the sense that, hey, we don't need a schema that needs to be generated. We don't need you to define any of the types manually in that sense. It doesn't need to be somebody who needs to manage the schema between the front end and the back end. It's all done automatically. So what that means is whatever you write in the back end will automatically be able to take advantage of and see the types in terms of you typing out the actual endpoints just automatically. It'll just like suggest the right endpoints that you're going to hit or the right requests. So it really just, what it does is it abstracts the idea of having all the requests in a single like endpoint that matter. That's tRPC, that allows you to make requests and take also advantage of the idea of batch requests the same way that GraphQL does. So without all the headache of being able to manage that schema. Now, who is this for? So typically it's, if you have like a big team and you're like, hey, you have a backend team and you have a front end team and they don't talk as well, or talk as much rather, GraphQL might be the best choice for you. If you are using, if you're a team that have like a very small team and you're like wanting to build out like a backend and a front end full stack application, you might want to have more hands-on with that and spend less time trying to define all these schemas. tRPC might be the solution for you for a smaller team, but it can definitely scale up for those larger applications as well. REST would be, there are still some things that you still need REST for. And I don't know if GraphQL has updated things, but when it comes to file uploads, you still want to use REST typically, specifically for file uploads that go to, I don't know, AWS or for whatever storage endpoint that you want to use. REST is still the best, because what ends up happening for a lot of these services like tRPC and GraphQL is it actually goes through a two-step process where you upload a file to GraphQL, and then it stores it temporarily and then re-uploads that, basically streams it back into AWS in terms of two-step process. So it makes your uploading like twice as long, and nobody wants to wait twice as long for uploading files. So REST is still kind of needed, but REST, the reason why REST is still around is, hey, a lot of applications need to use it. Some mobile applications need to use it. It's a lot of third-party applications that are somewhat legacy need to use these specific endpoints that are a little more conventional. So that's where kind of REST comes in, tRPC and GraphQL. All right, time to build. So first off, I'll just share this. I will be sharing an article and as well as the Git repository after this, so that we can kind of we can dive deeper into this much in terms of, hey, if you guys want to look at the code, if you want to follow the tutorial. I only had enough time to finish off somewhat of the tutorial, but I'll post the hash node URL and I'll make sure to update it afterwards so that you guys have a sense of what that looks like. All right, so time to build. But before we actually go into this, and while I'm setting this up, do we have any questions kind of coming through that anybody might be asking? By the way, I don't know if this is streamed on our in D&D potentially.
Yeah, it is. It's streamed on the YouTube channel.
Got it.
Yeah.
Nice. Okay, so no questions because I'm so amazing. Right.
That explanation was really good. I think you covered most of it.
Robots, do you have any questions for me?
No, not really.
Give me some questions, man. Need questions.
When build, man.
Okay, so we're going to start from scratch. And again, remember that I'm trying to remember every single step to this. This might be a little bit lengthy. I might be pasting code to make it a little bit easier for us to follow, but that way you get an idea of what we're kind of building from step to step. So one of the first things I like to do is I like to use the latest node version. So I'm using this is 16.17, but the latest one, if I'm not mistaken, is 18.12. So what I do most of the time in my repos is I set up an NVM C file and I paste that in. So if you have NVM installed, if you're not familiar with the NVM, I definitely recommend checking it out. It's like known version manager, basically. It's this. It allows you to download multiple versions of Node, and I just like having the latest version and seeing if there was something that there's cases where there's certain versions of Node that only work with certain projects, and I've been in those cases before where you're dealing with a legacy project where it's like on Node 7 or something, and you need to use that specific one and enforce it. So this is just an easy way to be able to go set up your NVM RC file, and then all you do is go NVM install, or if it's not already installed, and then it'll switch to that version. So now we're on node 18.12. Perfect. And then, like I mentioned before, we're using PMPM. So if you're not familiar with PMPM, Let me just bring that up. So very easy disk manager. So basically just use npm, but you just add a p to it, and all the requests are prefix with a p into it, and all the same requests are the same. All the same like package installs, etc. All the commands are all the same. It just makes it a lot easier. So we'll be using pnpm for this. Okay. So to start off, we're going to be using Lerna. And normally you go npx Lerna init, but we're going to go pnpx Lerna init. Okay. So what this will do is set up Lerna and the necessary packages. And Ropats, let me make sure that I see your face because I need to see it. All right. So you'll see that it's gone through. It's set up Lerna. Great. We're also going to set up Git just to have it initialized in that sense. And you'll notice that it creates like our packages folder. So basically all of our repos in terms of our different services, so like our front end, our back end, whatever services will be their own separate folders. And we're going to start off by creating our back end. We'll create our front end as well. So our first step is really to create the packages.trpc file folder. Okay. So while we're in there, so let's go into our packages.trpc, and we're going to go pnpm init. Okay. And we're going to install a few different services. So I'm just going to copy this because nobody needs to know this by heart, but I'll go over briefly what this is. So what we're installing, you see how fast that was because pnpm is already has all the libraries installed. So you have TypeScript, signing with Ethereum, Iron Session, Ethers, Express, Ethers, .env, cores, types for cores, types for Express, and type for node in that sense. So, and I believe, let's just set it up to make sure that we also have TypeScript initiated in this case. Oh yeah, sorry, I've got a pnpm install. Let's see. That's so weird. So it didn't install the other services. 1 second. Let's, so ethers.env, cores, add types cores. What do we have? Types express, types node. So a little bit slower. All right, so now it's installed. So now what we're going to do, because we have TypeScript installed, let's just reload this again. We'll see that our TypeScript installed. We're going to take advantage of that by using the tsc init. So basically initializing a tsconfig file for us so that we have installed. And we're going to set up our first server, which is our backend server using Express. Now you can use tRPC by itself as an existing server, but one of the reasons why I still use Express is because let's say you want to take your app a little bit further and you're going to be doing file uploads, etc. You might want to consider that down the road. In that case, you have the best of both worlds. So you're going to being able to still use REST like REST endpoints and still be able to use tRPC in that sense. So that's why we're using Express in this case. So it's an adapter, but you can use tRPC directly to be able to set things up. So I'm just going to set up basically our first application. What we're going to do is I like to separate my apps in terms of app and server, server.ts. And we're also going to create a new .env file. And I always like to create a .example file. And we're going to set it to port equals 5000 as an environment variable. And I'm going to pass this over here and make sure that I have a get ignore in here. So we'll add a get ignore as well. And we're going to add node modules. And we're going to add our .env to ignore as well. Yes, there we go. Okay, so what I'm doing here is going to create our first server. So basically what that means is we're going to import Express and cores. These are the first things we're going to do. I like to separate sections in terms of comments. That's just me keeping it clean. We're going to initiate Express in that case. And then we're going to add some configurations to it that we'll need for Express in general to make sure that it's working correctly. So we're going to use app.use. I'm going to take advantage of ExpressJS. So that allows us to be able to interpret JSON payloads going back and forth. And then we're going to use app.cores. So in this case, because we have two different applications in terms of local port 5001, which is our backend, and we're going to have probably a different port for our front end. We need to allow cores, but we need to take a step further in terms of configuring it to allow all connections. So to do that, we're going to go origin. It takes a function, which is the origin URL, our callback, an arrow function, and we're going to do callback. In this case, all I'm saying is that every origin is going to be true in that sense. So it accepts any from any website. So ideally, you want to modify this later on to kind of like to establish like a certain whitelist. So it's a good way to be able to say, hey, I only accept like 3,000 in terms of the specific site to accept requests from there to make it a little bit more secure. We're also going to take, because we're going to be using sessions, so not like typically most applications that you've seen in terms of Web 2 have been using like JSON Web Tokens, etc. So we're going to take it a step further in terms of going old school, but it's still one of the most secure ways of doing authentication, which is taking advantage of sessions with cookies. And we can take advantage of cookies to allow those requests going through and actually supporting that by just saying credentials true. So that's all we're doing, is we've configured cores in that sense. So, and then what I'm going to do is I'm going to add a route. And this is a default route that's typically for DevOps. So you'll see like this route called HelZ. HelZ is, or HelZ, is basically a route that's used for a lot of DevOps to be able to check the status of a server or check the status of an endpoint. It's like, hey, is the server still looking good? And this is like an endpoint to just be able to say, hey, yes, everything's good. Keep running, like everything's A-okay, basically. It's always a good convention or a good practice to be able to add like this route to things so that essentially you have that check for DevOps in that sense. I'm also going to add like a VS Code settings to this, so that by the way, let me know, Robot, can you see my screen perfectly?
Yeah.
A settings file to this to allow, and let me just shoot. I'm just going to add this formatter to things. This will just make it a lot easier so that, you know, the font, actually, let's make the font like 14, so it's bigger. So that when I save, it like auto adjusts, etc. So we can see that a little bit better. Okay, so now we have this, and we're going to export the app. So why do we like not go directly to listen? The reason why I do this is sometimes you might want to run tests specifically on the app itself and not the server when it's running on a specific endpoint. So that's why I separate like the server and the app. So server is basically just going to import your app, and then when it runs, it'll run on port 5001. So let's go. We set up our app. Now we're going to do our server. This is really, really simple. I'm just going to copy the whole thing. Basically importing from our app. We're going to process our port. Set it, if it's not defined, we're going to default to 5001, and it's going to listen on port 1. So to run this, and just to see that it's working, we're going to add a script called nodemon. So this allows us to be able to make changes to our backend and have it refresh, so like almost like hot reloading. And we're going to go nodemon.source.server.ts. And let's run this just to see that it's working correctly. So pm run dev. Should be working with port 5000. So let me bring up a browser here. Localhost 5001. So we have no route for 5001, but if we check out HelZ, we have OK true. So it's working correctly. That's exactly what we need to do. So we established a base like Express server with a sample endpoint. Okay. Let's stop this. Okay, so next, what we're going to do is creating our first tRPC route. So in order to support tRPC, we need to add the tRPC server as well as the adapter for Express. So to do that, I'm going to go pm install tRPC server. Again, don't worry if you don't remember all this. You can rewatch this as a recording, or you can. I should be giving a written tutorial out fairly soon. Okay. Robots, any questions for me? Anything at all?
Actually, I did. Like usually when you're setting up monorepos, traditionally the packages folder already has setups of front ends, back ends. I saw this one had just like empty folder.
Yes. Yeah. So in this case, I installed the modules here. You can watch. I can actually delete this. Go up a directory, or two directories, and I go pm install. You'll see what it does. Oh yeah, I need to set up the workspaces correctly. This won't work because I need to set up the pm workspace. So just to show you what that looks like, I need to create a new file that supports pm. So it's called pm workspace YAML. What that allows it to do is just to recognize it for pm. Where are the packages for this? So once I do that, pm installed, it checks the workspaces, and then it's going to resolve all the node modules for it in its appropriate repositories as well. So one in the top directory, see that there, and then it'll go through and install the ones in the sub workspaces.
Oh, wow.
That makes sense?
Yeah.
So you don't have to go like in each one and go yarn install each time. So the only reason I'm doing yarn install in this case, in these ones, is just to expedite working on the backend a little bit more.
Mm-hmm.
All right, so we're back in tRPC here. And what we're going to do here is we're going to import, go back to our application. And we're going to import, I'm just going to do this here. I can't spell import, from at tRPC server. And the things we're going to import are init RPC and infer. Oh, well, let's get to that in a second. Okay. So the first thing I'm going to need to do is to take advantage of, oh yeah, I need to import also the tRPC Express adapter. So I'm just going to do star as tRPC Express, and I'll explain this for a reason why we have to do it this way. C server dot adapters / express. The reason we have to do this is actually some of it doesn't work. It doesn't have the types set up directly to be able to take advantage of everything that you need for the adapters. So you'll have to write it this way or import it this way to just upload it, to import it as a root file, basically. And the first thing I'm going to do is create what's called a create context. So basically what this is what it's going to do is tRPC needs a way to be able to interpret how its requests and responses are coming through. So the same way that you kind of saw what a request and response is here, it needs to understand like how the requests and responses are interpreted and like what types are applied to that, so that we understand, hey, this is, in this case, they're express. So the same way that you would have like a response type, which comes back and actually shows you all the response body and what that looks like in terms of it, or the request for that matter. It needs to interpret that in a specific way. And that's where the tRPC Express comes in. So we're going to create a type. We're going to call it const create context. So just to give it like context in terms of, hey, you need to interpret this a specific way. And it's going to ask for the function is going to ask for a request and a response. And this type for this is a tRPC Express create tRPC Express create context. Sorry, I'm like tRPC Express create context and check here, and we're going to send it basically back the response and the request. So all this is doing is saying, hey, I'm going to give it the context. This is the typing. Whatever you're passing it through in terms of the request and response, interpret it this way, and then send it back so that it can pass through and be utilized by tRPC. So small note here. Context to interpret how the request will be processed with Express. Okay. So the other thing that we need to take advantage of is we need to actually create a type for this, for context. And the reason why we need to do this is in order to instantiate, and we'll step this constant here. We're going to instantiate tRPC. We're going to go const t is equal to init RPC context, and we're going to go create. Okay, but it needs to interpret, that the typing for that in order from our create context. So in order to do that, we're going to create some types. It needs to interpret in a specific way from our create context in here. And to do that, we're going to create a new type called type of context. So we're going to go type context is equal to, and we're going to take advantage of something called infer async return type. Okay. And what this is basically doing, if I understand it correctly, is like whatever the return type from that create context is interpreted, and this is how it's going to help us out for our typings basically. And we need this to instantiate for or initiate for our tRPC instance for all our routes. Okay, so we have tRPC initiated. We have the type for it. We're telling it how to interpret all the requests and the responses. You can see that here. But now we need to establish our first route. So let's go down to our routes, and we're going to do this a little bit differently. We're going to create our tRPC route. So we're going to do a little bit different. We're going to go app router is equal to t router, and then we're going to pass it as an object. So in this case, we're going to create something simple like get user. Get user is going to expect a procedure. In this case, there's query and there's mutation. We're going to establish a query, so a get request. We're not going to do anything with the request. Okay. And if you remember, you can take advantage of request itself. Take advantage of using context, the full context, and you can go like context to be able to take advantage of that too. So, but we won't need this. And all we're going to do is we're going to do return. So we created our app router. The next thing we need to do is we need to create the route. And actually, let's move this up a little bit. We need to create the route that supports our tRPC request that works with Express. So to do that, we're going to go app.use. I'm just going to make it the second line here. tRPC. So this is our tRPC route. tRPC express.create express middleware. The router, we're going to pass the app router, which we just created. So the tRPC routes. And we're going to pass it the create context so that it understands how to interpret also the requests that are coming through for requests and responses. Okay. So this is everything that's supported in terms of all of our dedicated RPC routes. Okay. So that should be working. So let's go do pnpm run dev, and let's run this again, see what this looks like. Ooh. Can't find module express. Why would you not be able to find module express? Oh, yes. I've encountered this before. So one of the issues that you'll find is that it does the linking incorrectly here. So there's a fix for this, and I make a note of also an article that I've written to be able to fix this. This will happen sometimes. The improper linking will happen. All you need to do is go npm uninstall express, npm install express again, and it'll update with the right version and without the improper linking, so that it fixes that. Run dev, work now. Let's go to bring up our browser here. And if you notice, I'm going to go tRPC/get user, and the data is coming through.
You might want to zoom. Yeah.
I love this reset, won't like disappear. So there you have it. We created our first tRPC route. So all we need to do was, it's the same way as if you were creating like a regular REST like route. The only difference here is that you're basically, doing it within an object in that sense. And it's all through, one route, and it auto generates all the names of the routes in that sense. So you don't have to actually have to generate them yourself, or specifically name them yourself. It does it for you. So yay, we have our tRPC. So from here, as you can imagine, this kind of gets a little bit crazy in terms of, hey, if we keep adding routes to this, I could add another route to this, another route and another route. And you can imagine this just gets crazy in terms of how many routes there are. So we're going to take advantage of something called merge routes. And in order to do that, we're going to make it so that we can separate the folders out to make it a little bit more digestible. And that way, if we have something for authentication or users or to-dos, in that sense, we can separate them out in folders. So in order to do that, we're going to have to separate this out again for tRPC as a separate file. So just kind of abstract it a little bit. So we're going to refactor this a little bit. So I'm going to go trpc.ts. This is off. And this is all the same stuff that we saw before. So we initiate the server, but I want to keep the create context because we need that here. If you notice in our app folder, we use the create context later on here. So the only thing I'm going to do here is I'm just going to export it. So export our create context. Now that we can bring that into tRPC. And then we can just move our context here. So we no longer need this. Actually, we don't need this anymore. So let's get rid of that. Get rid of this. Basically, we're going to be moving it to the other side, and we're going to get rid of our tRPC routes. Okay, and the only thing that's going to give us an error is our app.router, basically, that we're going to need to import, and we're going to get rid of this as well. So the only thing we need to do is we're going to instantiate everything within our separate file. That looks like is, hey, we initiate it, expose the router. We're going to expose the procedure as a public procedure, and we're exposed to something new here, which is our merge routers, which we're going to take advantage of. And I just want to make sure I can export all of these. So export context T router public procedures, all this stuff is exported. So it just allows us to take advantage of it. And well, the funny thing is the magic here for tRPC is that you'll be able to take advantage of this on the front end as well. Okay, so we have this set up, right? So now what we're going to do is we're going to set up our app router. So I'm going to put this here as an interim, but we're going to expect this to work. So we're going to go app router from router. We're going to create a new folder for this. Okay. And we're going to create a new folder called router. And in it, we're going to create a couple things. We're going to create just for fun, we're going to create a user folder, a user route for this. So it's saying all users. And then I'm just going to reference one on the root of things. So what that looks like is, just to start off, I'm going to import our tRPC file. I'm going to set up our, what we're going to do is we're actually going to merge routes. So we're going to go our app router, a new defined app router, which we're exposing to our app.ts file. And we're going to merge different routes. So the first route that we're going to expose is a new user route. So I'm just going to set this up. So import user router from our user directory. And we're going to add user router. And that's the new thing that we're going to create. So the next thing we're going to create in the user folder, create another TS file. And similar to what we had before, but the only difference here is we're going to import the router and the public procedure. So that's, remember, from our tRPC file. And what we're going to do here is the same router that we saw before. We're just going to define it really quickly. User router equals router. And then if you remember, it's get user public. In this case, it's instead of t.procedure, we're going to go public procedure. It's still a query. And all we're going to do here is let's return a new message. So it's a little bit different so that we can kind of see something different. Hello there from a merged route. And we're going to export the default router. So if we look here, this is our new router. So we can do everything that has to do with users within this folder. So, get users, delete user, etc. Everything can be organized in that sense. And then we can reference all routes, like all merged routers basically within here, this master router basically. And then it's imported into our app, which is used here on our tRPC router. And if we run it again, the amazingness of web development. tRPC get user, you'll see that it works still with the new message. So this is just a cleaner way for us to be able to manage routes a little bit easier, so that we don't have to, so that we don't actually have to, have it all within one monolithic file. In that sense, we can separate them out in folders, and it makes it a little bit easier also if you want to write tests. So that's tRPC setup within using merge routers. Okay, so next up is we need to support sign-in with Ethereum. But before I jump into this, Robots, do you have any questions for me on this? Or are you already amazed that, wow, we're just creating regular endpoints?
No, I think this looks pretty good. One question is when you create the user router, which takes in the other, like all the user related routes, it does not add that to the tRPC extension when you're like looking it up on your port. So it directly does /tRPC/get user.
Yes, like it automatically generates it. So you typing it, you setting it up here is basically like creating the route automatically. It's just another way that it generates it. So that's not that different from, again, this is not the magic here. The magic is what you're going to see in the Express side of things, on the React side of things, where you can like literally reference like get user, hello within your actual front end to be able to, without what all the suggestions basically coming through. But you need to set this up this way. So that's a nice thing about, we're just setting it up to give you hey, we established a first tRPC route. Now we're establishing merged routes to be able to make it a little bit cleaner. And this is just making our lives a lot easier for setting it up going forward. Any other questions? By the way, I don't know how much time you have, because like there's a lot to this. This is a long session. I don't know if are you strapped in? Like do you have coffee? Because like this is just the back end, and we haven't even touched finished the back end to be able to get to the front end basically.
Yeah, man, I'm excited. I'm down for this.
Okay, awesome. Matt, I see Martin and Daiwat. tRPC is amazing. Just wait, we haven't even gone to the amazing part. Okay, so we're going to use sign in with Ethereum to be able to get things working. So if you remember correctly, I think it's on our packages. I think I installed it correctly. We have sign in with Ethereum. We'll have ethers basically to be able to, and we have Iron Session. So if you follow at all I definitely recommend checking out Wagmi under their examples. They have a sign in with Ethereum, and I have contributed to these docs as well. This is a Next.js application. So what we're doing here is a little bit different. We're creating a Express application that handles this, but all the same endpoints that we're trying to hit in terms of nonce, verify, me, and logout. We're creating all those same endpoints, but we're building it into tRPC. All right. So if you're familiar with this is the backend basically that we're building, but in a different way. So it's not using Next.js. Okay. So the first thing that we're going to need to do is we need to support Iron Session. So what is Iron Session? So Iron Session, and I don't know if they have an actual website, but let's bring this up. So Iron Session. So basically what it is a way to be able to handle session cookies. So if you're familiar with how older Web 2 and maybe even Web 1 applications, or if you're familiar with PHP, this is a Node.js native version of what you can do in terms of saving sessions and cookie and make sure that those cookies are not accessed from your browser. So sometimes you might actually see a cookie, and let's just go here under your applications. You can kind of see what cookies exist on this application. And on the client side, for a lot of applications, you can actually reference a lot of these cookies But if you, and I'll zoom in a little bit more.
Yeah, you might want to, yeah.
What you'll see here is there's this little thing called HTTP only. Okay, so what that means is that if it's set to HTTP only when a cookie's set from a server, that means that you can't access it from the client in terms of the browser. The only way to access the cookies are on a server, so like a backend server. In this case, like Next.js obviously works, and obviously Express or just Node in general will be able to access those cookies. But if you're building a front-end application, you can't actually, like the actual React application, you can't actually access these without a backend service. So Iron Session just allows you to set those cookies and not allow and manage it on the backend automatically. So you don't have to write all this additional code to make it easier to write cookies in that sense. So to take advantage of this, we already installed Iron Session. So what we're going to do is I'm going to import it. So import Iron Session from Iron Session Express. So Iron Session actually has like Iron Session for Next.js, and they have Iron Sessions set up for Express. So that's specifically we're using this version to take advantage of it. So to set it up, we're going to go app.use, because we're going to use it site-wide throughout our backend, Iron Session, and it expects a configuration. So our configuration convention is the cookie name, which we're going to give it sign with Ethereum. Our password, and we're going to set this up with our .env environment variables. So we're going to go process environment Iron Session password, or and this actually has to be 32 characters. So unknown Iron Session password. This is actually surprising. I found this out. That is exactly 32 characters. Right. So I was like really surprised about that. Our cookie options. Okay. Cookie options. Let's see. Cookie options. We're going to make sure that these cookies are secure. So in other words, it can be encrypted. So over HTTPS. So we're going to say secure is only if the process environment.node environment is equal to production. So we need to set up this new Iron Session environment variable. So let's just set this up here in our example first, so that we always have something to go back to. And the default that I usually use is, where is it? Complex password, at least 32 characters long. And you'll notice like I added .env example. That's so that you can copy it quickly, so that whenever you like pull in the repo, I'm always thinking about the next developer, what they're going to use. All they need to do is like copy the environment variable as a .env, so they remove the .example, and they can be up and running. So I just add that to be able to show, hey, this is the schema that you should follow. These are all the environment variables that you should fill out, and then you just need to copy it and then put in your actual values. So always thinking about the next developer. Always got to think about them. Okay, so we have that. So Iron Session is set up. So what else do we need to do? In terms of Iron Session, it's pretty much set. Like the only thing we're going to need to do is we're going to take advantage of setting up refactoring now our user as an authorization route now. So what this means is we're going to just rename this as user. And we're going to set everything up to have the same routes for our that support our sign up with Ethereum routes. So we're just going to change this for convention's sake. So auth router, I'm going to go in here. This is going to be auth router. And let's just change this to like the router. So the first thing that I need to do, if you're familiar with sign up with Ethereum, let's go back to the Wagmi sign up with Ethereum app. If you're familiar with sign up with Ethereum, it's a prompt, right, that you need to do that follows a convention with the full, and actually I could bring up the presentation, except that I lost it. 1 second. I love when I lose things. Okay, let's just bring up this application quickly. So this is this convention that we saw. So you'll see here, it's that message. It's coming from the specific request, what the address is, following it's a signed message from your wallet to prove that it's coming from that you're authenticating, and the nonce that's coming through. So we need to establish a nonce, so a unique value that's generated to the backend, so that you can verify it on your front end, send it back to the backend to verify. Because one of the issues, like early on with like these signatures, is that like you can sign a message and you're like, yeah, I signed a message, all good, right? But the thing is, like, you're kind of like patting yourself on the back and saying like, yeah, I'm allowed to go in, like you're not verifying, you're just verifying yourself on the front end, right? So with the back end setting up, is what this is doing, is saying like, hey, I'm gonna prompt you with a key, prompt you for your request for your signature. Your signature is going to finish creating the signature, send the signature to the backend, and then going to like kind of not decrypt it, but take out certain values of it to be able to reverse engineer it and find out if the nonce matches from the nonce that I sent you for the request. So that makes it one session, so that essentially you're logged in. So that way you're preventing other people not sending the same message over and over again, so that multiple people could be like, they could sign a message and just send it over to a backend and say, oh yeah, I'm logged in as Ropats, right? So this is a more secure way of being able to do this, basically. So with our backend, so the first thing we need to do is we need to establish a nonce. Okay, so in order to do that, we're going to take advantage from signing with Ethereum, something called generate nonce, because it's very, very easy. So generate nonce, and this is coming from our sign. By the way, I found out today that signing with Ethereum, the way that the pronunciation for this is called SIWE.
Really?
Yeah, they're saying it's pronounced SIWE. So anyways,
I don't think I can get used to that, man.
Yeah. Generate nonce from SIWE. All right, so we're going to create a new route called, I'm going to prefix all these with auth, so that we know that so that our routes are always started off with auth. So I'm just going to auth nonce. Same way, public procedure. It's a query. But this is the difference here. I'm going to make it an async function, and I'm going to get the context. Okay, full request with the context, right, that we saw before. And if you remember, context allows us to take advantage of the request that's coming through from Express. Okay, because if you put in requests like this is the full request, which also has the context, which was from Express, and you can get the request from there. But we're just going to extract it by just getting the context request. Okay. The thing that we need to return, okay, is, and I'll just type this up here. What we want to return is a nonce. Okay, we want to return issued at. This is a little bit different from the tutorial that you might have saw in Sign Up with Ethereum. The reason why you want to do issued at, and the reason why you want to do expiration time, is that way that when your nonce is set up, it is saying, hey, I've set up a cookie for you to read the nonce, and once the nonce is set up, it should expire within a certain amount of time. So that way you don't like leave it open so that anybody could take advantage of this nonce, right? You want it to be short-lived so that the back can be like, hey, yeah, this should automatically delete itself after a certain period of time. Okay, so these are the things that we're going to be sending back to it. So to set that up,
No, I was just going to ask, this route gives a query to the user on the nonce, like they basically generate a nonce on the backend and sends that query to the user.
Yes, that's right. So whenever you query this, it'll set up a nonce, right? It'll return those values. But on top of that, what we're going to do, which is a sneaky way, we're going to take advantage of cookies and sessions, is that we're going to embed the nonce in the cookie, okay? And what that means is that way, once it's coming from the backend, it's set to HTTP only. That means the user can't modify it. And then what we're going to do is we're going to read it as the request comes back to verify it. And we're going to look at the nonce, not from what they sent us, but from what was set at the cookie. So it's the cookie that we set and we're getting back, and they didn't have to do anything. Like, it's automatically set to check if that is the same value that came from the source, basically. All right, so what we're going to do is we're going to set up our session. for this. Okay, this is basically what we're trying to do. So we're gonna go ctx request going session nonce equals generate nonce. Okay. Now the first thing that you're going to notice is that the typings are wrong. Okay, the typings are gonna like argue, like it just what's the word I'm looking for? Are going to complain to you basically.
Yeah.
So we need to support this, and in a way to support this is we're just going to go create a new folder called types, create a new folder called iron session. This is my convention, but I think it's the cleanest way to do it. It's to match the package basically. We're going to create a new typing, and in it we're going to import our sign in with iron session and our sign in with Ethereum message, the type for this. Define a type. We're going to say, because iron session's already imported, we're going to declare a module saying, hey, iron session that's being used everywhere, I'm going to create a new interface called iron session data, and I'm going to allow you to support nonce, which is a string, issued at, which is a string as well. I want to add an expiration time, which also is a string. Because I'm like making these optional, so it could be undefined or string. And then I'm going to add sign with Ethereum, which also needs to be defined, and that type is called the type of sign with Ethereum. Okay, so basically all this does is it creates a type that is supported throughout the application. So now we don't see that complaint going through. But what you'll notice though, if I set this up right now, go pnpm run dev, it'll error out. Okay, it'll still complain that it's not going through. And the reason why it's not going through is that you actually have to go to your package.json in your TS node, and you need to add this one flag, files. What that does is it actually reads the files, like the types directory, and it interprets that everywhere so that when you do run it, everything's good. It's a small flag, but it's like I've gone through so many times of this to be able to figure this out. So it's really, really annoying. So we generate the nonce. Okay. We want ctx request. What's the word? The next one we're doing issued at, right?
Yeah.
Issued at. And if I'm not mistaken, our issued at, we're going to get our current date for this. So get current date. Copy this because it's a lot easier than typing this out. So get our current date. We're going to go issued at our current date dot to. By the way, everybody goes to string. Use ISO string. Honestly, that'll save you so much hassle because it actually supports that. That's what you actually have to set it to. So dot to ISO string. So issued at, session. Issued at. And then next thing we're going to do is expiration. So we're going to go ctx request session expiration time. Notice how our types are there. See, because we have our type set up. Yeah. Yes, so nice. So we're going to do a new date. We're going to pass in the current date. Okay. At the time. And then what we're going to do is we're going to add 5 minutes to this. So we're going to go 5 times 60 times 1,000 in terms of the number of milliseconds. So, and then we're going to make sure that it's to ISO string again. So it's the right typing. So basically all this does is it adds the expiration for 5 minutes. So this cookie is only like it will automatically delete itself after 5 minutes within your browser. Okay. Now that we set up all those sessions, what we want to do is we want to make sure that we save the session as well. So to do that, we're going to go await ctx request session save. Now that embeds in it. And what we're going to do is we're just going to copy these same variables over so that it's easier, so we don't actually have to. Okay, so we set up our first auth router for the auth nonce. So let's run this. Let's open up our browser. 1,000. We'll see that get user no longer exists.
Can you zoom in a bit? Yeah.
What I'm going to do is go auth nonce. Okay. And there we go. We've got our nonce, issued at, expiration date, like expiration time. And what I want you to notice, if I go under application, we can see that our cookie is set here. So if I did this again, you'll see that our cookie is set, and it's in a form that's encrypted, or like whether or not it's encrypted, it's done in a way using that password that we set up for our environment variables. So that way that it can only be decoded on our backend. So this is setting the nonce data, the expiration time, as well as the issued at, so that all of it's could be used for our backend to be read again. And for every request that we're interacting with our backend, this is automatically passed through. So we don't have to add any things to our requests or make anything special. It's always added to our requests.
And this cookie lasts for 5 minutes, right?
This cookie will last for 5 minutes. Yeah. So you'll see it here. Expires in. I love how you get it.
Yeah.
Yeah. Okay. So we set up our nonce. The next thing we're going to do is we're just going to create basically the rest of the routes that we need for it. So the rest of the routes that we need are auth verify, which is the next one. So auth verify is basically what we're going to be using to be able to, when they finish their signature, okay, they pass it through with the message, and then we validate, hey, that this makes sense. So this is a little bit different. It's not a query, it's a mutation. So we look at it, it's a mutation, and we're going to make it an async request. We're going to take advantage of the full request, and I'll get to that in a second. That's why we're using the full request as opposed to CTX in this case. And we're going to do, this is fairly simple in terms of the stuff that we saw before in terms of the signing with Ethereum tutorial. I'm just going to wrap this in a try catch, as there's errors that happen. Yes, I said errors any. And we're just going to do this one is return. Okay. False, and error as error message or known error. And let's just do return is, oh yeah, just any rather. So it's a mutation. We got to take advantage of inputs, right? So to take advantage of inputs and to have the typing set up, and to do validation on that, we could like set it up and just do all the, we could like just go request, go to the body, like get that in terms of being able to go, request.ctx.request.body. Like the values that come through that you would normally see in Express. But we also want like validation, because I don't want to have to write, message if message.length is less than 0, or message.length is, that's our message.signature is, and throw an error, etc. Right? Like this becomes really, really lengthy. So we're going to take advantage of another library called Zod. Okay. And I'm just going to bring up Zod here. So Zod is an example of what they recommend. So it's a type first schema that like validates as well. So basically all it does is it allows us to do input validation, as well as take advantage of it a little bit easier in terms of how we handle the requests. So what that looks like is we'll need to install Zod first. So npm install Zod, basically. So now that we have Zod, we need to import it. Z for Zod.
Wasn't Zod the villain in Buzz Lightyear or something?
I thought it was Zod from Superman.
Oh yeah.
Yeah, there you go. You got the wrong universe. By the way, I like to do this between my functions to make it a little bit easier, so that it's easier to read. So here I'm just going to go and call it verify. So it just gives a little bit of a visual break in between the functions, so you know how to easily find them if you're scrolling through it. So here, verify. So the difference here now is that we're going to allow for inputs. So inputs could be, you could set this up with the existing requests, but because we're using Zod, we can take advantage of a Z, which it's Z object basically. So it's expecting an object, an JSON object with a message. And we said we think that message is a string. And we're also expecting a signature with which is also a string. Okay. So basically, this is like handling the validation for us, saying, is this a string or not? Because if it's a number valued, or if these values are not sent, it's not being, what's it required? It's going to come back with invalidation, basically. So, but the nice thing about this is that we have the inputs for that object of message and signature. We can actually take advantage of it now in our try request. So we can go our const sign with Ethereum, like our SIWE message. It's a new SIWE message. I need to import this. And we want to import our request.input. See how I took the full request? Input dot message. That. So I don't have to do that request full, etc., none of that stuff. And I'll need to import this too, because we need this to be able to put this in the format for our sign in with Ethereum message. So I'm just going to. We have our signed message. And what we're going to do is we're also going to get our fields. So this is kind of cool, is that what it does is, if you're familiar with signing with Ethereum, what this does is it'll take the signed message, take the signature, validate it, and get all the fields from the nonce, as well as the expiration date, etc. You can do all that. You can get all the fields from that. And all we're going to do is we're going to remember how we said that the cookie was already set from our backend, right? So it's automatically we want to check that the message that they sent, the signature that they sent, the nonce that they sent matches the nonce that was sent from us when it was sent through the cookie. So in order to do that, we're going to go our fields not nonce is not equal to the request. This is the request.cts.request session nonce. If it's not equal to that, right, I want to throw a new error. This invalid nonce. And this will just jump down here and send a message to catch it and then pass over okay, false. Okay. So it's a way for us to invalidate, hey, this is not the nonce. This is not coming from the right user when we deconstruct it in that sense.
Yeah.
And what I want to do is I also want to save our session with the updated fields as well. So our session. And I want to make sure I save that so that it's saved again. And if it's validated, then it's coming back as okay, true, basically. I just want to say, hey, yeah, it was valid. It's coming through. So I'm just going to put a little note here about that CTX request, so that you kind of know how that mutation works, basically. That's right. Martin is talking about Zod runtime type checking. Yes, exactly. So now we have a way so that we get the nonce. They'll set up the signature. From the signature, they'll pass it on to this auth verify with the message and the signature, and then it'll verify if this is coming through correctly. Okay. So we're just going to add the last two things, which are the me endpoint, which is it reads the cookie, and if the cookie comes back with the actual with the address, so reading from the fields. So if we did this again, this is me. Me does public procedure. We take the context. We're getting the sessions, sign in with Ethereum. Notice how the sign in with Ethereum has the fields.
Yeah.
If the address is not there, we'll destroy it. Actually, let's not be so hasty. Let's just return the address. So basically all it's saying is like, if it's there, it's there. If it's not, it's not. So it's either address is there or address is not there. Okay. And then we're going to do logout. And logout's a lot simpler too. We're just going to destroy the session. So auth logout, it's a request query. I have our context. I'm going to go session destroy and just set to okay, true, like, hey, it's been destroyed, basically, the session cookie. And we can kind of see what that looks like too, taking advantage of this. So I've got npm run dev. Let's open up our localhost 5000. And let's go to tRPC auth nonce. And if you remember correctly, if you remember correctly, here's our sign with Ethereum. And remember, if we interact with the site at all, like health.z, etc., you'll see that the cookie persists. Every request is passing through that cookie constantly because of that session. But let's go to tRPC, auth, log out. There you go. I've destroyed the cookie. So now we can make sure that they don't have a session persisted on the backend with our front end.
Oh, wow.
All right. So we added everything we needed for the backend. We will need to do some refactoring on the backend just to take advantage of it. But for now, we'll jump into the front end. So we have everything we need so far to allow for signing with Ethereum on the backend. So next thing, I'm going to create a new folder using Vite. So if you are unfamiliar with Vite, it is a front-end framework, basically, or scaffolded application, almost like Create React App. If you're not familiar with Create React App, it's a scaffolded application, but this is using Webpack, and ViteJS is using ESBuild. And if you don't know what ESBuild is a bundler, which is much faster than Webpack. You can see that 0.33 seconds for bundling things as opposed to 41 seconds. It's a lot easier in terms of, and it's built in, if I'm not mistaken, it was built in Go. But there is another bundler to take advantage of, which to look out for is like BunSH, I think. Have you seen this? Bun apparently is supposed to be even faster than ESBuild. So check out Bun as well. But it's like very experimental, but it's kind of cool. It's even faster, which is crazy. Oh, all we're doing is we're creating a new package. So looking at the prompts, React, TypeScript. Okay. And let me just double check that I installed it in the right directory. I did not. All right, let's do some cleanup here. I'll just move this to here, and we'll remove the packages folder here. So it's the same. Perfect. Okay, so we have our React application. Let's just test this so that it's working correctly. So let's go pm install. Sorry, not run install, but install. Almost there, 40. Done. Okay, nice. Let's just run this. pnpm run dev. And let's see what that looks like. You'll notice it's on port 5173. If you're familiar with this, this is like the default UI, basically, that we're using for React. So we're going to tear it apart, basically, because there's some things that I like to install. So what we're going to do is we're going to support Tailwind. If you're familiar with Tailwind, if you're not familiar with Tailwind, you should be. Like Tailwind is the bomb. Tailwind is just like a CSS framework that allows you to easily create UI. And I'm just going to be copying and pasting a lot of this because I don't want to keep you here forever, but just making sure that we have the UI done in a nice way. So we're going to follow like basically the convention for VJS in terms of installing things. So I'm just going to install it and add the support for it. So what I'm going to do is in React, just refactoring. Okay, perfect. Install Tailwind. And this on the development side, but I'm also going to install Wagmi, Ethers, and sign it with Ethereum. This is what's needed on the front end. We'll install that. Give it a second. All right. And then what I'm going to do is pnpx tailwind init p, so that creates our tailwind config file. Give that a second. That'll be here. And the only thing we need to do here is add this one line to be able to interpret from the index.js, index.html file and all the source files, all the components in here. And lastly, we want to add to our index.css, remove all this and just replace it with this to support Tailwind. And then I'm going to remove some stuff because there's a lot of stuff I don't need here. So I don't need the assets. So I'm just going to delete that. I don't need the app.css file. I'm going to delete that. And what I'm going to do is I'm just going to add some refactoring for this to be able to make it a little bit cleaner because it's like OCD for me. So I'm just going to go imports, render, and then add semicolons because I like semicolons. Are you a semicolon person? Semicolons? Yes, no.
Oh, do you ask me? Sorry, no, I'm not a semicolon person. I mean,
I need it. I need to know that like when you're at a sentence, that's when you end the sentence. Basically, that's for me. So I'm going to copy and paste this. I'm just going to replace all this, basically showing you what the default UI that I'm going for, just briefly. So new state, I have a state that's set up here with some values that can be undefined, Boolean, nonce, expiration, nothing crazy. And this in our render, we have a title, some buttons, etc. What that looks like. So briefly, what this looks like, if you want to see what that development environment for this.
So quick question, and I might be like jumping ahead of myself, but earlier when we were just trying to render the default route for the route, we didn't get any result. So is this what is supposed to be shown out there?
What do you mean the default route?
Basically, when you ran the dev environment on your backend.
Yes, because for our backend, we didn't actually have any routes for the default route. If we wanted to, like if we went to app.server, if we wanted to, we could have one that's like the route.
Okay.
If we wanted to. We just didn't add that because it wasn't needed, basically. Saving on cold. You could add one as well. Sometimes what I do on these is like I pass through, like sometimes you might want to know what the version is for your backend without like divulging too much. So you might go like version and you might like, 1.00. And that way, when you go to your root route, you'll see your version. You might even see, like what's the node environment. So sometimes you might want to pass that through.
Okay.
Be able to say, hey, like at least like I'm keeping track, like what backend what version am I running again, so that I know what front end to kind of interact with it in that sense. That was the backend basically. Semicolon for life, yes, Martin. And create T3 app we will get to in a second, actually. We'll get to at the end, which is something to consider too. Okay, so you can't use create T3 app with this because this is not Next.js. This is Express as well, and a React frontend with a single page application. So just to see what this looks like, this looks ugly. Let's just, there's one thing I forgot to do here is in the index.file. I'm just going to go class, and I'm going to go bg zinc 9000. And then we see what it looks like. So this is the UI that we're ultimately aiming for. We can connect, we can disconnect, we can see the wallet that's connected. We can do our prompt for sign with Ethereum. We can see what the message results are, retrieve the user session info. So if the user's session is still active, we can retrieve the address, basically. That's that auth.me. And then we can log out, which is essentially our destroying the session or destroying that cookie. So this is the UI, and we're going to add the functionality to it that we're going through. All right, so I'll put this to the side, and we'll get to this in a second. Okay, so now we have the UI. We're going to add support for Wagmi. And to do this, one of the ways that I do this, I actually like to do, and this is, I probably recommend other people do this as well, is like adding all your providers in one place and have it wrapped in a single provider. So, and what that means is like, I'll have a folder called providers. And one second here. Wow, I'm like, I'll have in my providers, I might have an index.tsx file. Might import like my providers, like all providers here. We'll go here. Here's the root provider. Const root provider. is equal to children, which we pass to it. And the children is a React node. And I'm going to return a div, which in that div, I'm just going to pass in the children so that it passes through. And I'm going to do the exports. It is probably complaining because node. That shouldn't be the case. Let's just import React. That way it's not complaining. So now it's saying like, hey, whatever my root providers are here. What that does is that you can add other providers, or like Wagmi provider, or like you had like a browser router as a provider as well that you wanted to do. You put everything here, and then what you do is once you have the providers, sorry, this is not set up because it's not in our source folder. That's why it should be here. So this should be done this way. You don't need that because it's inferred. So what we do here is go to our main, and what we're going to do is we're going to import our root provider, and then you wrap our entire application with just one provider in that sense. And then this contains all our providers. And what that looks like is like one of the providers is we need to have is Wagmi. And I like to separate these out in different folders so that makes it easier for organization's sake. So I have my Wagmi provider. So we're going to configure Wagmi. This is going to be the simplest version of Wagmi. So all we're going to do is our create client, our Wagmi config, and the default provider, which is coming from the browser. So basically using the provider as in whatever MetaMask is using to be able to make any requests. Okay. So we're going to do a configuration from that to create a new client. We're going to auto connect, or the provider is the get default provider from Ethers.js, right? And then what we're going to do is we're going to create a new provider called Wagmi provider. Provider called Wagmi provider. And test it. It has children in it as well. And the children is a React node. And all I'm doing here is I'm going to return Wagmi config, where I'm passing in the client so that we can access it everywhere else as a context. And I'm going to pass the children to it. And lastly, I'm just going to export it. And what that does is now what we'll do is we'll just import our Wagmi provider. So import Wagmi provider. And then what we'll do is we'll just like wrap it here. So every time we add new providers, we'll just like continuously add them here. And then it just wraps our entire application. It just makes it a lot easier. So now we have Wagmi set up. So now we want to do our like wallet connection side of things. So now that we support that, now we can actually take advantage of like connecting your wallet and being able to sign the signatures. So to do that, we're going to use a few different functionality from Wagmi, which is use connect, use account, use connect, use disconnect. Okay. And we're going to put this under our hooks. I also like to separate different sections like state props here, my hooks here, requests, functions, on mount. So my use effect basically. So here I'm going to take advantage of our account from use account. So our address as well as our account. And then we're also going to take advantage of our use connect, which gets which allows us to have the connect so that we can connect our wallet, which prompts, and then we'll have an injected. We'll need to take advantage of the injected. So basically what that means is, hey, whatever the injected connector is, in this case, it's the default from Ethers. And then we're also going to have our disconnect so that the user can actually disconnect their wallet. Okay. So now that we have that, we're going to add some additional functionality here. So really simple. We're going to say if the user is not connected, show this button. If the user is connected, show this button. And I guess I know you could write like within the same one. Maybe let's just do that. Why not? Make it a little bit cleaner. Is connected. And we're going to add the functionality as well. So we're going to do onClick. Connect. OnClick. And then we're going to also add just like a small error log. So it's like sometimes the user might disconnect and they didn't or they didn't connect properly. So I'm just going to add like this one line here, which allows you to say, hey, if there's that error connection or there's an error disconnecting, I want you to show like an error message, like unknown wallet error, like show that message or an unknown wallet error, basically. And lastly, we want to make sure that if only show the signature stuff if the wallet is connected. So is connected down. And if it's not connected, so null. And let's take a look at our application now. So let's disconnect. And I just want to remove the site so that I connected sites. Let's just remove this. So let's do connect. It'll prompt me again. Let's go cancel. It says, I reject the request. I'll connect my wallet. And now I have access to sign in with Ethereum, etc. And let's add that last little bit to show the address that's connected. So we'll just go here, wallet connected. And we'll show the address. When we go here, say, hey, we're showing the address that's currently connected. Okay, so we have the basics. Now we're going to start adding the support for tRPC. Okay, so for this, we need to take advantage of the tRPC client. So we need a few different things. So we need the tRPC client. We still need the tRPC server. We need React Query, and we're going to use TanStack React Query. So these are the recommended things that you need installed on your computer, installed for the client, basically. All right, so they're added. What we're going to do is we're going to create a tRPC that's going to take advantage of our backend for this. So in order to do that, we're going to go into our source. We're going to create a new folder called utils. And we're just going to call it, guess what? tRPC. .ts though, not TSX, but TS. Okay. So we're going to import the create React query. Okay? And what we're going to do, we're going to import, we need the app router. Okay, the type of the app router. So in other words, we need the type of app router we saw from our backend. And this is where we need to kind of go back to our tRPC, go to our app. Go to our tRPC. No, it's here, sorry. Our app router, which is already exported. Okay, that's perfect. So we don't need to do anything there. So we'll just go app, one, tRPC, source, outs, and we need, we need the type. This is where we need to basically add that type as to be exported. So we'll go to here under our router, and we'll go a new type, type app router is equal to type of app router. That's how it is, right? Well, let me just double check here. Type of app router. So we'll need this for our front end, basically. And we're just going to export it as well so that we can take advantage of it. So export app router. Okay. What that does is now we can take advantage of this type. So to connect all our typings. Okay. So we have let's just finish off our tRPC. So what we need to do is we need to configure our tRPC client. And notice how we pass in the typings of app router. So what that does is saying, hey, I want you to listen to all the routes here, take advantage of that. And then so that it makes it a little bit easier for that type suggestions. And we export it. Okay. So next step, we need to add support as providers for tRPC and TanQuery, basically. Okay, so I'm going to create 2 new folders here. tRPC, query. And the first one we're gonna set up is like React query. So index.tsx. And I'm just going to copy this and just go over the code altogether. So I have my create client and my query client provider from the React query. I'm instantiating it. And I actually want to, let's leave it like that. Except for one default option that we're going to remove here. So this is if you're familiar with React query, you can set these default options. And one of the things I hate is like refetch on window focus. It's so annoying. It's like if a query, like you unfocus and you focus back on the browser, it'll refetch and perform the request again. I hate that. So we're creating query provider. We're passing in the provider in that sense, and we're passing in, the query client and children again. And what that does is now we can go back to our main provider, okay, and we can import that. So let's go import provider, and we can just wrap that. So now we have support for use query, use mutation, etc. Next up, we need to add tRPC. And for tRPC, we're going to take advantage of something called batch link. This is great. This is essentially what we need so that if we want to do batch requests, we can fully support it now, the same way you do in GraphQL. So now we can have multiple requests go through with a single request in the most efficient way possible. So we're going to import tRPC because that's what we need for this as basically our client. And we're importing it from our utils. Okay. Utils at tRPC to take advantage of. And we also need to import our query client. Okay. We need to tell it what method are we using to be able to process the requests. And if you looked before, you'll notice that I exported the query client, which was here as well, so that we can take advantage of this. This is needed for tRPC. So the 3 things I need. So config. This is how you set up your first client. So basically in here, and we need to set this up as a provider too, right? So const tRPC provider children, and you guessed it, children is a React node.
So when you said we're going to make like batch requests, can you elaborate a bit on that?
Yeah, so what that means is like, let's say, not that we need, and this is unfortunate, it's like for this specific tutorial, we're not going to need it. But like, the same way that you do in GraphQL, you might ask for like a user information, their to-dos and all that. In REST, you might make separate requests. And GraphQL, you can do one request and you can perform all those requests on the back end, right? You have one HTTP request. So with batch requests, you basically do the same. It's automatic. You can do multiple requests that are batched within a single request. So you can do multiple, like get nonce, get me, get all this stuff all at the same time, basically. So very, very advantageous in terms of, hey, now I don't have to for multiple requests. So tRPC provider requires a query client, which is the query client that we had before. And it needs a tRPC client. So our client is our tRPC client. Okay, we need to finish it. So we'll export it. We're gonna get to the rest of the configurations and why just in a second. Export default tRPC provider, and just like the other one, we're gonna import it. And I believe the order does matter, so we need to do the tRPC above this.
Why does the order matter?
In this case, actually, it might not, because tRPC is not needed before that. It probably could work the other way around too. Yeah, in this case, there's sometimes some providers require, refer to like hooks from another provider. So in that case, it might make more sense. So let's try it this way. Maybe there's something that I missed, but yeah. Okay, so the config here for setting it up. So we need to pass in what's called links, the configuration, okay? And it's an array, which is a bit interesting. We're doing batch links, okay? And we're going to set up the default URL. So React ViteJS has environment variables, but they're just done a little bit differently. And they need to be exposed on the front end. They need to have a prefix of Vite underscore. So we're going to take advantage of that. So we're going to say there's an import meta environment Vite tRPC server URL / tRPC. Okay, so that's the default. We didn't even need that. We just need the default URL basically. So we're going to add that. We're going to add 2 new files. We're going to go environment.local. And we're going to do environment.local.example.
So, quick question: what is this environment.local file? It's kind of different from what we usually use.
Yeah, so it can read actually environment. Local would be like if it's not production, right? But there's like even production, etc. So this is a convention by VJS actually. So you can see all of it here. So basically it just goes over the environment and the mode that's in. So depending on like if it's dev or prod, like if you're doing yarn dev, then it'll probably run dev, but local is also for local environments. So in this case, it's just a convention that they introduced. So loaded in all cases, ignored by get ignore, loaded in all cases, only loaded in specific mode. So you can load different environment variables depending on your environment, basically.
Right. Okay.
So I'm just a local, and we're going to follow this server convention here. So let's go to our environment. Sorry, this was supposed to be .local. And we're going to pass it HTTP, localhost 5001, tRPC. And let's add that to the local as well. So it's in the local example. So if you wanted to, you can quickly copy it. So that's our base URL. Okay. One thing here, you can actually modify the requests a little bit. One thing that you'll note here, that things won't actually get saved. And I'll show an example of what that looks like briefly in a second. So just to do this. That's like our base that we set up for our tRPC client. So now we have our tRPC client set up. Now what we're going to do is we're going to go into the application and perform our first request. And this is the magic that you're going to kind of see in terms of the, so basically the typings that come through. So here we're going to go under our app file, and we're going to import tRPC tills tRPC. Okay. And what we can take advantage of now is under our requests, I'm going to const auth nonce, okay, is equal to tRPC. Look at this, auth nonce use query. So now, if this data goes through, if it's successful, I get my data, and watch this, expiration time, issued at nonce, all brought in from our backend, basically. We don't have to worry about like remembering any of that stuff. It's all like all the types are set up automatically for us. So this is the magic of tRPC kind of seeing the types coming through for us to take advantage of, in that sense, in a monorepo. One thing, and then we'll just see what this request looks like because I just want to see what it looks like. To do that, because if you're familiar with like React Query, when the component loads, this will automatically get fired in terms of the request that goes through. Okay.
Yeah.
So we're going to change it later, but I just want to use a use effect here to be able to see, one, is the user connected, and auth_nonce.data to see if it's gone through. So I'm just going to say if the user is not connected or auth_nonce.data is not defined, return. And if it is, I'm going to go set state. The state is existing state, and then I'm going to go nonce auth_nonce.data. So it'll set it in the state. Okay. So that once it goes through, we'll see it in our UI basically.
Mm-hmm.
And I think I actually need to, I need to set that up here under, where did I put it again? Yeah. No, it's already set up state. Okay, perfect. So let's go back to our application. But I also want to look at the requests. Okay. Some requests. I'm going to go sign with, it should perform the request already. It says error connection. Aha. You know why? Because our backend isn't running. So let's go to our backend. Sorry. tRPC, PM, dev.
Oh, you might run this.
Oh, sorry. CD tRPC, PM. Let's clear this up again. Let's clear this. Let's run it. And we'll see our auth nonce comes through. We got our nonce issued at, everything's set up. Now we're performing a request and we're getting the data back. Okay.
Mm-hmm.
But there's an issue. Where's our cookie? Cookies aren't going through. What's happening? Nothing's coming through. And the reason that's happening is because we need to modify our fetch requests to include credentials as well. That thing that we said we need to come back to. So what that looks like is we need to support credentials in other words, passing of cookies back and forth. So that's here where we said we're going to come back to it. So just say needed to support cookies. We need to go fetch, which is a convention they have for which is fetch, right? Which expects the URL and the options. And what we're going to do, that needs to be common here. We're going to return fetch in general. Return fetch back. But we're going to pass in the URL. We're going to pass in all the options, all the same existing options, but we're going to add credentials include. So if you're familiar with fetch a little bit, like the fetch API.
Yeah.
That basically allows you to, for same origin,
you might want to zoom in a bit.
Yeah, to allow for cross origin for cookies to go back and forth between different sites to support that. So the setting of cookies and passing them back and forth. So you need that set up in order for things to go through. So let's try this again. All right, one more time. Let's refresh. And now we have our cookie set up. So now it's automatically grabbing the cookie every time we refresh, sets a new cookie each time. Okay. This is where some refactoring comes in because we don't actually want it to, if we don't have control over it, it's sort of like a race condition, right? Where like this is always being set, like the new nonce. We actually want to be able to control this, like to only call it when we actually need it. Okay. So we don't actually want, like there in use query or React query, there's this option of lazy queries, like you use lazy query. We can do that too by just disabling it. So we can go enabled. Was it? Oh yeah, we need to pass in null first because there's no value, and then we have access to the configuration. So enabled equals. What this does is that now get rid of this cookie and let's go to our network. And if we go here, we can see that no requests have been made to our auth.me and no cookies have been set. Okay. So as far as it goes, like we have control over, hey, this shouldn't go through. By the way, you should just ignore this. For some reason, it's always, even if I set it as undefined. There we go. That's what I needed. This allows us to say, hey, don't like load this the first time the component is loaded. Now we can actually control this a little bit more by using something called auth nonce. So the existing query, and we're just going to go refetch to be able to perform a request. We actually don't need any of this right now. Okay. Next. Still with me, Ro? Still with me?
Yes.
There's a lot to go through, but we're almost there. Like we're getting there. basically.
I think you've built up pretty well to it, so it's not too lost.
Okay, awesome. Okay, so the next part is that we're going to add is for the signature prompt. Okay, so this is a bit longer, so we'll need to do that. We'll need to get the nonce, and we'll need to take advantage of auth verify. Okay, so this is another one. This is a mutation. So we're going to go auth verify is equal to tRPC, and again the types are there. Love it, right? And it's a use mutation in this case. Okay, this is a use mutation. Yeah. Okay. And we're going to take advantage of that because it works differently, not like a get request. You have to call it specifically to be able to pull in that function. So in our functions, we're going to perform a sign in. It's an async function. This is when the user clicks it. We're going to do some things. So we're going to catch it in the catch as well, because there's some things that can happen in terms of errors. And we'll just place it. Okay. So the first thing we need to do, and this is following the same convention from Wagmi's side of thing, we just check for the chain ID to make sure the chain ID has been set, because that's actually needed for the signature. So if we go back up here, we need to add something called use network. Okay, so use network, and from use network, we're going to go chain use network. So what this says is just saying, hey, what the current chain that you're currently on with your connected wallet, what is that chain? Because we'll need to know that. So, and we can get the chain ID. So we're getting the chain ID, and we don't want to continue if we don't have the address or we don't have the chain ID. If we don't have either of these, we shouldn't continue. Okay. But once we do, I want to set a state of loading just to show that it's the request is performing. So we have those things, and we're just going to say, hey, I want to show that it's loading. So let's just see what that looks like briefly. So I'm just going to click here on click, sign in, and let's open up our browser. And you'll see like is loading true, so that we show like some sort of status in that sense. Okay, so now that we have is loading, I need to create a signed in message with the nonce that we kind of created, okay, that we just retrieved. But if you remember correctly, we disabled the nonce. So what we need to do, we need to get the nonce asynchronously from the auth nonce. So what we'll do is we're going nonce is equal to await auth nonce refetch. Now we have the nonce, and we can actually add this to here now, because if we have the nonce, we'll go nonce is equal to nonce data. Yeah, sorry, nonce is equal to nonce. That's the same format, the nonce issued at expiration coming through, following the same convention. So we have that. So now we're going to create a new message. We're going to take advantage of it with our new sign with Ethereum SIWE message. Such a weird name. But we need to import that from our SIWE. And then we got to follow this convention. Okay, this is a little bit different from the tutorial that you might see from Wagmi, because we add the expiration as well. So domain is the same. We're just going to go window.location, post. The address is the same. The statement is sign in with Ethereum to the app. The URI is window location. Oops. Location. Origin. Version. Just to one. Chain ID. Expiration time is set to our nonce data expiration time that we got from our auth nonce. And we're going to set our issued at our nonce data issued at, and then we're going to pass in the nonce. So let's just copy this in this. Okay, so now that's our prompt. Okay, and what we're going to do is So that's our prepared message that we want signed. So we're going to go get our signature. We're going to await sign message async. So we need to take advantage of this function, and to get that function, we need that actually from Wagmi. So we'll need to take advantage of something called use sign message. Add that hook here. Sign message async. And the message that we're signing async is the message we're passing through. So we're going to go message, and the message that we just had, prepare message, format that it needs to. And let's just console log what that signature, like what that message and the signature looks like, just so you can kind of see what that looks like. Let's go here, sign in. We get our prompt, all the data, the nonce, etc. Sign, and here's our sign with Ethereum message and our signature that we're going to be passing through in terms of the to the backend. Okay.
Perfect.
Oh, in order to do that, we're going to take advantage of our mutation. So we're going to go auth verify mutate and pass in the message and pass in signature. But you notice there's an issue here. To sign to Ethereum is not assignable to type string. Okay. If you remember, this is why I said we need to come back to this. To auth verify, we set our message to string.
Yeah.
Okay. But it's not a type string. It's a type of signing with Ethereum, which is different. So there is a way that you can do, technically the way that you should do this is like instance of, and then you could do like sign with Ethereum or whatever, right? And that should work. But let's see here, because last time it didn't work correctly. So and actually let's just add a catch here. So is loading is false, the nonce is undefined, and whatever error is set as error. Yeah, okay, perfect. Okay, so this shouldn't work actually, from what I remember. Oh yeah, we got the nonce, etc. So let's perform our request. Let's sign it. Fatal. Yes. Okay, you'll see here, input not an instance of sign in with Ethereum message or SIWE message, right? It doesn't like the types for that for some reason, and I think this is something they're going to be working on. But in the meantime, there is a workaround. So what you just need to do, which is a little bit annoying, because it just passes it as a string, is that you need to set it up so that it's just an object, basically.
And so you have to create an object of that specific format.
Yes. So what that would look like is it's a message object. I'm just going to separate this in 2 lines. What that looks like is this. And this follows all the values that were set basically from the sign in with Ethereum message.
Okay. Right. Yeah.
Why is it? Oh yeah, it's going to give me an error. Even though it's the object, we're just going to go as sign in with Ethereum message. So basically saying, hey, no, you should interpret it as a SIWE message. So it should be working now. So now we go to our front end. Let's try this again. Sign in with Ethereum. Let's look at the network because it should have gone through. Result, okay, so that means it went through correctly and that it did validate. So just to prove that it works, we need to also, you want to check if it's like invalid. So let's set the nonce to something like weird. One. So it's invalid all the time. So let's try this again. Sign with Ethereum. And if we look at the network, we'll see that it's false, invalid nonce, basically. And we should see it in our errors. Well, we should see it in our errors, but I think it's always coming back as the data. So what we need to do is we need to do a catch for our mutate. So we're going to take advantage of our use effect again, but only for the mutation. So this is our auth verify. Okay. And if our auth verify is data is not set, if it is set, we want to say if auth verify dot data dot is not okay because it's a variable. Actually, we want to say if it's okay first. And what I want to do is set the state to loading false. Okay, and say that it's signed in. The user's actually signed in. Else, if they're not okay because it's invalid, I'm going to show an error. Whatever is false is loading false, but the error for auth verify data show the error message that was coming through. That was what we saw here, the error value, basically.
Yeah.
Just like pass that back to be able to show into our UI. This will just like hook into that. Let's try this again. We should see it in our UI. So we're go through our signed in and say is loading false, signed in false, invalid nonce that went through. Now, if we went back,
it is also like storing some data from before.
What would it be storing before?
So when you clicked on the sign in, there was also some data from before there. You can see
the nonce. Yes.
Yeah.
That is because if you remember here in our sign in, we performed the auth nonce request and then we're setting it right away. So it's just getting the nonce data basically that's needed. And then once it has the nonce data to pass in this, to set up the signature, set up the message, and then prompt for the signature, and then pass the message and the signature to the backend.
Gotcha. Right.
So now we see that it's signed in true. So it was valid. The signature was passed through. We can even see that our application cookie is set up correctly. So everything is set up. So we've successfully done the sign-in, but we want to take advantage of the retrieve user. So this is a good way to set up, even if you want to set up middlewares, to be able to retrieve the information from the session. So that's the next one we're going to add, which is the auth me. So to do that, we're going to follow the same convention of auth me, of not enabling it. And we're also going to another one called auth logout, if you remember.
Yeah.
And make sure that it's not enabled either. So in order to do, we're going to do a new function here. We're going to call it, should we call it like me? No, what did I have it before as? Yeah, let's just go like get me. Let's just call that async press. And we're going to go await auth me refetch. Once we have that, I want to set the address because this is actually the address from this turn. And we're going to go set state x, so whatever the values are before x, and then we're going to pass in address as address dot data address. That makes sense. So we're just using this get me, and we're going to do that for this button, which is the auth me. So we're going to go click. And now, because we're logged in, oops. There we go. Now that we're already logged in, because our we already have our cookie set up. Retrieve user session. And we'll see that the address is coming through again. So, and this is coming from, we'll see that the network auth.me returns the address of somebody that's actually. So if we did this again, like let's remove this cookie. And let's go to, let's clear this. And when we do retrieve user session, it returns nothing. It's null. So that's when we're not logged in. So we have the get me retrieves user information based on a cookie, session cookie. And the last thing we need to do is, because I just manually removed that cookie, we need a way to be able to destroy the cookie with auth logout. So we're going to auth sign out, because the other one sign in, because it's already confusing with naming conventions. Destroys session cookie, logs the user. And do this same. It's gonna we don't even need the const in this case, so we're just gonna go auth refetch. After it's done, we're gonna go set state. And what we're going to do is double check here. We're going to just set the address to null and set the thing to them signed in as false, basically. The cookie. So we'll go here, click sign out, back here. Let's go through the entire process again. So let's disconnect, check my applications, no cookie is set. I connect. The prompt for, notice here the nonce has been set already within the cookie. Like, then we'll perform the request. I'm logged in. Let's fetch me. And let's actually set this up for auth.me to show the UI for this as well. So let's just say here will be state.address. So let's retrieve the user information, which is the address of the user that we're signed in. Now let's log out.
Right.
And if we do log, we should actually say is signed in is equal to state.is signed in, not signed in. So like they're logged out. So let's log them out. The user, which should be null. We destroyed our cookie.
You might need to, yeah,
the opposite, sorry. Let's just say is signed in true. So is signed in false. So let's go through the entire process again. I sign in. I'm signed in. Retrieve the user information. Here's my address. I'm going to log. If I log out and I click retrieve user, it's always returning null in that sense. So now we're able to do the whole entire process of signing with Ethereum with tRPC, essentially. So all the same routes, which is great. So, but you can do batch requests in that sense too. I did want to get at creating maybe an extra step to this tutorial too, to be able to allow you to have gated information. So like if you went to another page, you wouldn't be able to show that information if they're already signed in, if they're not signed in rather. So, but this is basically the entire step of being able to sign in with using sign in with Ethereum, retrieve the user information, destroy the cookies as well, and make sure that you're signed out. All using tRPC basically. So the last thing we want to do is we want to add a script so that when we're coming into this, we don't have to go to every individual folder, right? Okay. And we want to be able to add a script here where we just do dev, and we're going to take advantage of Lerna that's already installed. So load modules .bin Lerna dev. So now,
Oh, I think you got a typo for learner.
oh yeah, you're right, Lerna. So now when I go pnpm run dev, it'll run the front end and it'll run the back end, all within one command. So here's the front end, and here is the back end, all within the same step. Look at that, man. The entire thing. And that only took almost 2 hours. So let's, oh yeah, I want to remove these DS and stores. I hate this stuff. So let's remote add origin, tRPC, sign SIWE, Monorepo. So I'm just going to add that. Git status, git add, and then I'm going to use my favorite pnpx git cc. You know about this?
Nope. What's this?
So it's like a convention for commits.
Mm-hmm.
So you can follow this is a in this case it's a feature. It's the initial commit. Initial functionality for entire application. Breaking changes, no. No existing issues. This is nice. You can choose which packages you want to commit to. So both of them. I've added that to the commit log, right? And then I just got to go push origin main. And let's check it out, man. I think we just created a repo. Boom. So now if anybody wants this code, they can go to codingwithmanny/tRPC, sign in with Ethereum, SIWE, Monorepo, basically. But hey, if you're any good developer, make sure you gotta have a README, man. You gotta have a README. So this is the tRPC, sign in with Ethereum. The way that I like to structure mine is there's requirements, setup, and the requirements are NVM or node version, say 1812, PNPM version PNPM 715, and then the setup is we have to create environment variables. So the way that I like to do it is you can in our React. So variables. This from the root directory. Do is packages react dot environment dot local dot example. Oh yeah, and copy that as environment dot local. But I'll make a copy of that. And we need to do that for our tRPC backend as well. It is tRPC example. Is my bad. Next thing you do is start our application. Run dev. Before that, npm install. Do this. Expected output. Yeah. And sometimes this is a project that demonstrates using SIWE. Sign
CV is really catching on.
Yeah, with tRPC, using a Monorepo setup with Lerna. There will also be a YouTube video for this entire tutorial coming soon. Perfect. Oh, and lastly, I like to do this. Preview. Create a README folder. And I always like to just get this file of what it looks like, or a screenshot of what it looks like of the current application. Screenshot. And forget how it is for images. Do you remember how it is with the convention for images again?
I
don't
remember. Let me quickly look that up. I think it's bang apostrophe, bang colon or something.
And then like the image, like readme app.png. From preview. Oh, is it just readme? Markdown, image, insert. Done this for a few. Forgetting. Okay, it's
it's like syntax for links, but with like a bang before that. Yeah, pretty much.
There we go. Get status, get add, and then follow my favorite convention again. So that's commitizn. If you're not familiar with commitizn, commitizn is like a tool, and this is just a package to be able to have conventions for when you do your commits. So that's where that came in, where when there is now I'm doing a docs update. So full readme, updated readme with instructions. Changes no is there we go. That's the proper way to do at least a base readme. So there you go, man. Also, one small tidbit, and it will come later like today, I promise. Or well, maybe this week or whatnot. 1 second. Just one other announcement. Wow. Yes. Is the article with the entire tutorial is up as well.
Oh, wow.
It needs some changes. But I'll have the updates as well up on it, and I'll make sure to post when we have this YouTube video up as well set up, so that I'll make sure to add that as well to this. So this is a base, but the entire article is up. I also, surprisingly enough, if you want to go like the Next.js version of this out,
Mm-hmm.
GitHub coding with Manny. I actually have a repo for Next.js as well that's set up using Next 13. So
Oh, wow.
Next 13 is different. So everything is in your app folder now, but your APIs are here. So if you ever want to know how to do signing with Ethereum with Next 13, there is some really interesting things that you have to keep track of. Like this actually shows you an app, and I'll show a small preview of this just briefly, so that everybody can kind of see what this looks like, so they can play with this themselves. Let me just bring up my terminal. Next 13. It's becoming soon too. npm run dev. So a lot of this is experimental.
Mm-hmm.
This is the application. The way that it works is, if you want to go to the profile page, you need to be logged in. I'm logged in. I can sign out, but if I try to go back to that page, I'm using sign in with Ethereum, so I'm not logged in. But if I sign in, I can now verify my account. Yes, go to my profile. Go to my profile. I'm in. I can go to any page. Go to my profile. If I sign out, then I'll be automatically logged in, and you'll see that the UI changes here. So, but you'll notice that there's some things that are nuances here, that you have to do things like server-side checks, and you have to do client-side checks. So it's almost because there's a lot of things that are kind of hybrid in that sense too. But I definitely recommend checking it out too if you guys have time. That is another tutorial that I will be writing to be able to show that. But for now, focus on tRPC, signing with Ethereum, Monorepo. This is it. I'll be posting. This is the first draft, so I'll be going over it. But yeah, it's long. There's a lot of code to it, but it goes off over this entire tutorial. But I'll post the YouTube link in this as well. Robets, do you have any other questions for me, man?
So when are you like coming for your second session to teach us about the gated version of this?
The gated version, right?
Yeah.
Yeah, I thought about that too. Like I think that I could do like an update to this as well. So I'll just say right now, like that you look in the comments below for that second video or whatnot. Hopefully I'll have it up to be able to show what that looks like for having like using gated routes and gated ways to be able to show, hey, is somebody signed in? Can they not like access? And what that actually involves is making another provider that you keep track of if somebody's signed in or not. But it's a little bit different because remember, you can't access the cookies. So you have to have a way to be able to do it once and verify it and catch the HTTP requests as well. But yeah, there you go, man. This is the entire step. Any other questions for me, man?
Not really. Like perhaps in that like other session we can see the batch links as well. Was really like curious how that works. But apart from that, like I think the way you've like built up the entire process was pretty well explained. Like I think you covered most of the concepts without like having any previous context on it. So it was amazing.
Are you now going to learn? Are you going to try to do tRPC now going forward?
Yeah, 100%. I'm gonna. Quick question. I remember you saying something about providing some information about create T3 app early in the session.
Yes. Okay. So yeah. So there's create T3 app. Okay. So this is built. This is equivalent to like create React app, right? So another scaffolded application. It is opinionated. It is actually by Theo. If you don't know Theo, you should follow on YouTube. He's very opinionated. So he kind of worked on this specifically. So this is a scaffolded application using tRPC, but using Next.js. So it has and even has a version using Vercel's new Turbo Cache or like Turbo Repo. So you can set up a Monorepo, but then also what you can do is like you could take advantage of all these caching abilities with Turbo Cache too. So this is just another scaffolded application. And remember, my goal with this was to originally do something that was just like, hey, let's not do Next.js. What are the alternatives? Because client-side applications are really, really important still in the ecosystem. There's a lot of people that are building on client-side applications. If you want to take advantage of Next.js, you can still you can do that. You can do hybrid versions of like SSR, like server-side rendered applications and client-side. It just gets a little bit more complicated. And you kind of see like the nuances in Next 13, that repo of how like I handled slight different things in terms of the UI changes when somebody signed in, and it's a little bit tricky. But here you can scaffold this out. It's already set up. It's very opinionated. It's great. I would like to dive deeper into this as well. I haven't had enough time to be able to go into this, but it's a great base to be able to start with. The other thing to factor in is, I was going to say with this is, this is not with signed with Ethereum. So if you want to do it with create T3 app, go to town, you'll just need to set it up with Next Auth, which is something that Wagmi does or covers. I recommend checking out under their examples for signing with Ethereum. Under the bottom, very, very bottom, you have signing with Ethereum Next.js application with Next Auth. Okay. This is by the Spruce team. So this is the guys that the company basically that set up signing with Ethereum. So if you went to login.xyz, this is this official signing with Ethereum page. And it was like built essentially by Spruce. And then they got just a collaboration with a bunch of people, and they set up another example of what that looks like using Next. Because the way that we did it was using Iron Session, and this is using Next Auth, which is native to Next.js. This is another way that you can do it. The way that I did mine for Next 13 was using Iron Session. This is using Next Auth. You can also use things like Passport.js with this as well. There's a new sign-in with Ethereum Passport.js. So that's another thing to consider. But these are little small like nuggets if you're trying to do it with Next.js. I'll try to do a tutorial too, specifically on Next.js 13. Hopefully that will be soon on how you can do sign-in with Ethereum basically.
Looking forward to that, man. So once again, guys, like quick shout out. You can follow Manny on Coding with Twitter. Coding with Manny on Twitter.
Coding with Twitter, yes.
Oh, we don't want to get into that. But yeah, thank you for the super amazing workshop. Looking forward to having you again on this, man. And yeah, guys, I will update the links with all the articles that he's mentioned once they're out. And yeah, see you all on the next session of workshops.
You got it,
guys.
My pleasure. Ciao.